So you never know. Hey, it's all good. What are you gonna do? What are you gonna do? Awesome. Okay. Exactly. Yeah. About to make a hot toddy or something. Jeez. That's awesome. All right. Can everyone see my screen okay? Should we get started? All right, beautiful. Okay, so same thing as last time. I am recording this, so you don't have to show your faces. No problem at all. This will be posted on YouTube for you guys. Tonight we're going to go over exam number 2. Feel free to type a question into the chat or just interrupt me. It's totally okay if you have a question. So exam number 2 will be a week from today. It's going to be on Tuesday, November 5th. And you'll have all day to do it, starting from 8 a.m. till just right before midnight to submit it online. And it will include our, let me see if I can zoom in on this. All right, it'll include the juice treatments, alcoholic fermentation. It'll also include secondary fermentation and sulfur dioxide. And it will also include our pH TA lab. I think we talked about pH a little bit in the last exam, but we didn't really go over TA. And I was supposed to upload an answer key on Canvas for you guys, but we'll just go over it today together in person so you guys can have those answers for the exam. Sound good? All right, awesome. Okay, so I'm just going to go ahead and jump into juice treatments. Let me know if you can't see anything. I'll try to make this a little bit bigger. Okay, juice treatment. So this is what we do to the juice before fermentation. I have my green screen tonight, so there we go. Okay, now my face is out of the slide. Okay, so 2 things that can happen to juice before we start fermenting, and that's clarification or additions. So clarification just clarifies the juice, literally. So this is a juice sample before fermentation, and this is a way that we can help clean the product to facilitate downstream processing. Just makes it a little bit nicer to work with when you get to the end. So I do think this is important. What is cloudiness and how is it measured? So cloudiness is known as turbidity, and that's measured in NTUs, which are nephelometric turbidity units. So nephelometric measurement of turbidity. Basically, the larger the NTUs, the more hazy or cloudy your product is. The lower the number of NTUs, the more clear it is. So this comes into play with large scale wineries when you start looking at the filterability of wines. So like the more haze it has, the more like pieces that are, what's the word I'm trying to say here? The more particles in suspension, and that will actually make it more difficult to filter because there's so much gunk suspended in the wine or the juice, right? So turbidity is a measurement that we look at for clarity, for like quality, and like it's a cosmetic measurement, but also like on the filtering side, whether or not it will be filterable. And that's very important for large wineries to look at because filters and for large wineries are very, very expensive. I worked at a winery that had a cross-flow filter, and there were 6 cartridges of it, and each cartridge was $10,000. So you don't want to mess that up by putting something that's not compatible with that filter into the system. So that's important. Okay, moving on. Methods for juice clarification. We have natural gravity settling, centrifuge, filtration, and flotation. Just know that these exist for the exam, and I think you'll be okay. I might just ask you what are some ways that you could clarify juice before fermentation, and I might ask you why would you want to clarify your juice before filtration, right? And that just goes back to the where were we? That it facilitates downstream processing, right? So it just makes it a cleaner product now, so that way there's less work down the road. Okay, natural gravity settling. It's the cheapest practice because it's free. It's the most common practice. You know, stuff just naturally will settle out of suspension, and then you just rack it off very carefully. You guys have done this in class. I've seen you do this. You guys know the concept. Centrifuge. just like that, on a much smaller scale, that device next to the Liza in class is a very, very large machine that does that on a very large scale. This can be great. You know, the products do end up clean, but there can be some downfalls. You should know the downfalls of each of these things, right? So I could ask you, like, what are the downfalls of centrifuge? You'd say you could get some aeration, so, you know, oxygen intake, and it can also strip too much from the juice too. You want those nutrients and some of those solids for fermentation. Okay, filtration. This is always such a funny picture. Um, filter. I know it looks like someone like harvested an organ. Sorry, it's the Halloween week. I'm allowed to say it. Okay, so for filtration, we usually do a rough filtration for juice, right? It can be difficult. The lots of sugar content, very viscous, and you're also dealing with everything else in the juice, right? If there's any leftover seeds on accident or pulp or whatever, it can be a huge pain. So, you can do a rough filtration before fermentation, but you would wait to do the finer filtration, like the sterile one, until your wine is finished. Okay, flotation. This is when we apply a gas like nitrogen to push all of the gunk to the top. And then you can skim it off the top there. Or you can, if this is on a tank, on a large tank scale, this pumps all the froth, the grossness to the top, and then you can pump out of the tank until you start seeing gunk. And then you're good to go. So we actually don't see this very much in the United States. At least not the wineries I have worked, but I heard that this is very common in Germany. Okay. So far, so good. Additions for juice clarification. We have bentonite, PVPP, and activated carbon. Sorry, that's my water heater from my tea singing in the background. Um, so just know these three different things: bentonite, PVPP, and activated carbon. So bentonite is the clay that we added to our white wines to help them settle, right? And it did help them settle a little bit. Um, this is a clay. You want to add it as a slurry to your wine. When we move into the lecture about finding agents, we'll talk about bentonite more as its role in being a heat stability additive that we use for wine. Well, it becomes find out, so it's not like you're consuming it. Don't worry. So yeah, this is important. I would say it's really important to know that it binds to all positively charged particles because it's negative. So just like a magnet, it comes together. It is important to make it a slurry before you add it to your wine because it's most effective when it's in a water slurry rather than in a wine slurry. And that's just to do with like the pH of water versus the pH of wine. And also you would lose wine in that process because it would soak up wine rather than water. Okay, and added, oh, this will be important, added at the very beginning before yeast. So we're not adding this with yeast, right? We're doing this before yeast, rack it off the bentonite, and then we'll add yeast later. That's when it's most effective. So put a little star next to that. Okay, PVPP, polyvinyl polypyrrolidone. Say that 5 times fast. Here's your new Facebook password. So this is a cool product because it prevents and treats oxidation. So if you had a whoopsie and you left your wine out to too much oxygen, this could be a product that can help you. It's also helped reduce bitterness and prevent peaking. Sorry guys, these words should be bolded. This is when I was a noob at writing slides. But those are going to be important to know for sure. So I might give you a question of like, hey, you have a tank of muscat juice and it's already turning pink. What are you going to add to it to help it out? So this could be a possible answer that I would accept is PVPP or activated carbon. This slide is always so creepy. Okay, if you are using carbon on your teeth, I'm not a dentist, but I don't think it's a good idea. Anyways, carbon is non-selective. It binds to everything, right? So which makes it a very powerful finding agent, right? So this can be used, we'll talk about this in the finding agent lecture, but it helps to remove lots of components of wine. So if you want to use activated carbon as a possible answer for a solution to a problem I present you, that's okay. But I need you to recognize that it's very severe and non-specific finding agent. I have used activated carbon and treated a white juice with it, or a white wine, and it literally tasted like vodka and water afterward. Like, just tasted like alcohol. There were no aromas, no color, nothing. So if you're gonna use that, just recognize that in your answer, and I'll let you go. But don't go adding activated carbon to everything. It's not gonna be a good time. Okay, so far so good. Okay, beautiful. Thank you. Okay, moving on. Having a little too much fun here. I need to keep going through these slides. Okay, primary fermentation, also known as alcoholic fermentation. Right, so the yeast that we use in our wine is used in lots of other things, turns out. Rum, cheese, laboratory experiments. I have a friend who works with special like beauty companies, and he works specifically with fermentation products for skincare. So look, that's kind of cool. Okay, so yeasts are a single cell unicellular fungus that reproduces asexually by budding, right? So it's just like some crazy monster out of a horror film. Just like literally divides itself. It just keeps going and going and going. And it's capable of converting sugar to alcohol and also creating carbon dioxide in the process, right? So it's used in beer, wine, general baking medicines, etc. I do think unicellular or single cell and fission is important for the exam. I would like you to know that. The type of yeast in the winemaking industry, if you could identify or be able to identify these yeasts, if I say what yeast is most commonly used in the wine industry, I'd like you to be able to say Saccharomyces. And this just means species. No, it would be a multiple choice. It would just be like, what yeast is most commonly used in the wine industry that does not give off flavors and aromas? And then it'd be like multiple choice, and you just be able to see it and recognize it. Yeah, good question. I won't make you spell any of these big things. Cool. And then we have native yeasts, which are, I swear to God, if you say natural yeast, you're going to be in trouble. Native. They're all natural. Native. All right. Brett is bad. We know that, right? It's bad for the wine industry because it smells like horse sweat and fecal matter. So if someone says your wine smells like poo-poo, you might just be a bad winemaker, but it could also be Brett. So now you won't forget. All right. What is fermentation? Sugar and yeast create carbon dioxide, heat, and ethanol. What's the fun part? The alcohol part, right? The more sugar, the more alcohol. We saw this when we calculated for our potential alcohol questions. I'm not going to have you guys do that again on this exam. I think you guys got that down. I do think it's important, though, to identify why these values could be different, right? It's important to be able to see what we did and look back and identify what could possibly have gone wrong, right? So the yeast, it could be that your yeast are super efficient at converting sugar to alcohol, and not all yeast are the same. Some yeast are super hard workers, and some of them are just not that efficient, and that's okay. They're all different. It could be an inaccurate initial sugar reading, right? Like, it gets crazy when we harvest things with raisins on them and the sugars spike all of a sudden the next day. And the sugars could keep spiking throughout the second day. Even when we press that to nut, we noticed that the harder that we pressed, the more sugar came out of those raisins that were left behind in that barrel. So it could have been an inaccurate initial sugar reading to start. So just being able to identify that is very important. All right. So we all know what a stuck fermentation is. It's when your fermentation decides it quits. It joins the union. Decides it's over it. I'm just kidding. It's a horrible joke. All right. So that would mean that you have a wine with residual sugar, right? And so if there's nutrients available, some kind of microorganism will utilize that, right? It's not always the good guys in the park. Sometimes we get the bad guys coming over too. So that's when you can get vinegar potentially. So spoilage is bad. So that's why we care if our fermentation finishes. If we're doing this for like a stylistic reason, if we want there to be sugar left over, then we would need to take the time and care to sulfur it, filter it, chill it, make all these applications so that way it does not start to spoil. That's why we monitor that so much. Okay, common causes of stuck fermentation. You're going to want to put a big star on the slide. I will definitely ask you about this. So, lack of nutrients would be definitely a big one, right? You didn't have enough nutrients to run the marathon. Don't be upset that you didn't run the marathon well, right? If you had 2 hours of sleep and you only ate a Krispy Kreme donut and a 5-hour energy on your way to the race, you're not going to make it. It's not going to work out for you. So, yeast assimilable nitrogen, just being able to identify that. DAP is one. You have to be careful not to add too much nutrients in some cases because then you can start to call over the less favorable microorganisms as well. Okay, so nutrients, lack of nutrients, heat is another one as well. You want to have a successful environment. Yes, yes. So you want to make sure you have sufficient nutrients. Put a star on this slide too. Oxygen when you want it and when you don't. Temperature and alcohol inhibition. Does someone have a question so far? No? Okay, good. Okay, so sufficient nutrients. So sugar, we have to have sugar to convert into alcohol, but nitrogen is a really big one. So most wines are nitrogen deficient. It will help fasten your fermentation. It will also make them more resilient and will increase the population. So it's a win-win-win. Oxygen, during the beginning of fermentation, for the yeast to develop healthy cell walls, they actually need oxygen in the beginning there. So that's one of the reasons that pump over can be so helpful and punch downs is you are introducing a small amount of oxygen to help the yeast be healthy. And the wine is so young at that point that oxygen is not really a problem, right? And also your fermentation should be progressing at that point too. So there's so much dissolved CO2 and everything else in there that it's being protected. Okay, the yeast cell growth phase curve. I'll definitely be asking you about this. So we'll want to, okay, good, I lined it all out. So we're going to want to identify the different parts of the curve. I might ask you, what is this part of the curve? What is this part of the curve? And then I might ask you, what's happening at this part of the curve? And why is this flat? What's happening here, right? So that's all going to be on this slide for you guys. Lag phase, you just added the yeast. You're not really seeing a change in Brix much because the cells are just becoming acclimated to their new environment. Then we have acceleration, growth, decline, stationary, and death, right? So death phase could be because of temperature, because of alcohol, lack of nutrients, right? How would we know what part of the growth phase that we're at if we can't look at the cells in the tank? We look at the rate of Brix being consumed, right? So that's why it's important that we measure Brix every day in an ideal situation, right? So if we just added yeast and we see that Brix are not moving, then we know, okay, it's probably the lag phase, right? But if it doesn't start going crazy in the next couple of days, then something's wrong, right? For the next couple of days, you have a huge acceleration and growth phase. Yeast are recreating and like spawning more and more yeast, and they should be consuming sugar during that portion too. So you should see a huge drop in Brix at that point. And then stationary phase, those Brix will level out, and then death phase, you'll see no change in Brix. So that's a. Mm-hmm. All the above. It could be any of those. Yeah, they could be dying because they've consumed all the sugar that they can, and now that's the end of it. If you keep supplying more sugar, they could keep living, but then yeah, up to 15% alcohol, they die off too. Or if the tank gets to 120 degrees Fahrenheit, they all toast. But yeah, that would be the death phase. All of the above. Hmm. If you added sugar and nutrients, it would reactivate, but I wouldn't know unless you sent it into a lab if it was the yeast that you had originally inoculated it with or if it was native yeast taking over. You know what I mean? Yeah. Yeah, really good question though. It was kind of an interesting year for us as winemakers because it was so hot this year. Some of the wineries that I measured that dropped off samples didn't add malic bacteria at all to these tanks, and they came in measuring at 0 malic acid. And I thought that was very strange, but Paul Bush from Adronia had told me that it's happened many years before for him during hot seasons, and he just has like a underlying culture of malolactic bacteria that resides in his cellar, and says some of his wines don't need it. So I thought that was crazy, especially in a tank and not necessarily a barrel situation. But yeah, pretty wild stuff. Okay. Yeah, no problem. Temperature. So if a temperature is not warm enough, right, the yeast won't ferment. So you think of like bread. If anyone's a bread baker, um, it's like that, right? So the proofing drawer needs to be at a certain warmth for it to repopulate. But too hot, is too much. There's also too cold, right? So there's a sweet spot. Typical red fermentations, I mean, these numbers are so trivial, man. I've seen fermentations get up to 100 degrees and be just fine. This is what the textbook tells us. 45 to 60 is ideal for whites and rosés, but 60 has been the mark for a lot of wineries I've worked at. 45 is like you're crawling at like zero point 0.2 bricks a day. You're just beating the crap out of that wine. It'll be a slow fermentation, but if you can afford it. All right. So I'm not going to ask you these numbers specifically. I think just understanding that there are ideal temperatures for fermentations, and generally whites and rosés run cooler and reds run warmer typically. Yeah, question. Right. So for the reds, that's the temperature of the fermentation on the skins. Yeah. Yeah. And then for the white and rosé, that should be the temperature withheld in the tank during a white or rosé fermentation. And so we'd set the tank to. But then after fermentation, um, you'd want to keep the reds closer to 65, like cellar temp. And then whites and rosés, if you're going to cold stabilize it, you'd freeze those tanks. But then ideally, you'd want to keep them relatively cold as well until it comes time to bottling. Then you'd let them warm up if the warm up to room temperature, because if the wine is too cold during the bottling process, you'll get condensation on the glass and your labels won't stick. So tank temperature, there's a lot of coordination that's done with that. All right, alcohol inhibition. So if you're having a hard time finishing a fermentation, might be because you had too much sugar to start with and your alcohol levels are really, really high. It's very normal. Most yeast can't make it very far past 15%. I've seen 15.5, 15.8, even 16. That is remarkable. But generally speaking, 15% was when alcohol inhibition starts to take place, right? So it becomes very difficult. All right, how do you feel about this calculation? Because it'll definitely be on the exam. Silence. All right, so the big thing to remember, right, is C1, V1 equals C2, V2, right? But take a look at this example and make sure that you guys got this, right? So it's actually C1, V1 equals C2, V2. So V2 is your end volume, but it's also, see if I can do this, my sick brain. It's V1 plus X, right? It's your starting volume plus however many gallons you need to add, right? So when you look at this formula and you apply it over here, oh, I'm moving stuff. It's important you have the initial concentration, right? Initial bricks, initial volume, final desired bricks, and then our volume is the initial volume plus X, or X plus that, either way, tomato, tomato. Then you multiply, you can distribute this through, or you can divide both sides by 24. I'm not going to be mean and give you a multi-step example where I ask you to calculate your gallons and figure this out. I would just give you these values to begin with. I'll be nice. So just make sure, you're welcome. So just make sure you write out the formula correctly. Take your time, right? You can use a scratch paper. You can use a calculator for this exam. You can use a calculator on your phone. That's fine. Write out your steps. Show your work. You know, taking it back to the old days, and you'll get to your answer. And then just make sure when you type in your answer, you don't have to show me. If you can show me your work, that's nice. I appreciate it, and I give you partial credit if you got something wrong. If you can't show me your work, that's fine, but it's really important that you tell me, I didn't even do it on this. This is hilarious. Wow, real hypocrite over here. Gallons of high quality H2O. Units are important, right? Not gallons of acid or gallons of antifreeze. This is gallons of water. Yes, units are important. All right. Correct. Because you're going to be removing the must, so you don't want to over add, right? So for this formula, I would give you exactly how many gallons of juice. Like I would do like a white wine or something more simple. But for the calculation of the ratio, what we've used in class before typically is the 150 gallons per ton, and a ton is 2,000 gallons. So it would be 150 gallons divided by 2,000 pounds, so 0.075 gallons per pound. And if you did need that on the exam, I would supply that for you. I would give you that that ratio, or I'd convert it into something that's a little more user friendly. Because 150 gallons per ton is really just a guideline. It can vary a lot depending on what variety you're working with, what vineyard, how old your vines are, all that stuff. So that's the hard part about winemaking is some things are very accurate and some things are like, well, we kind of just work with it. Cool. Good to move on? All right, gorgeous. All right, yeast flora. Okay, this is just the yeast and bacteria that lives on all the surfaces around us, known as ambient yeast, native, wild yeast. But we're not going to use the natural word because all yeasts are natural. Yes. Lovely. Okay, the importance of temperature and fermentations. White wines, you generally want them cooler and slower. Red wines are typically warmer, and that's because we want to extract all the color, phenolics, and tannins from the skins, right? So taste, color, and mouthfeel. Cool. Makes sense. Different types of vessels. I did ask you this on the quiz. I'll probably ask you again on the exam, like what's most, like compare and contrast the advantages and disadvantages of an egg-shaped tank versus a stainless steel tank, maybe, So you guys did a really good job with that on the quiz, so just review that content again. I'm not going to ask you about badinage. That was just a fun fact. This is just a fun chart to reference for when you guys are doing your personal projects for a type of oak that you want to add. We have American French and Acacia. Unfortunately, we don't have Hungarian. But if you'd like to reference this chart, if you guys are interested in adding oak to your project wines, you can kind of see what general flavors might come with that. We have medium toast on the American and the French. Okay, interstave. I'm not going to ask you about that. Okay, so far so good? Okay. Thank you. I'm dying on the inside. All right. So, nitrogen. What was that? Aw, thanks. Chug it. No, I'm just kidding. Don't do that. Okay. All right. Why do we use nutrients, right? So, nitrogen is very, very important. It's used in lots of different types of nutrient products, right? Unfortunately, this presentation was not sponsored by Scott Labs or anything, but maybe one day. So we talked about nutrients, Yan, and the timing of our additions, right? So what's the this this is fermentation nutrients. Yeah. I don't have it. Oh. Surprise, surprise. Okay, not on the exam. Yeah, I think we skipped. Alright, if you say so. Moving on. Do you guys want me to post this just for your information? Yeah, no, this won't be on the exam. Don't worry. Okay, let me take it off this so I don't accidentally. Oh, okay. I guess I just opened it for fun there. Okay, oh well. Yeah. So when I first started this class, 5 years ago, it was just like my VITI 303 class where it was my first time teaching and none of the content had been written yet, and I had a lot of home winemakers from the El Dorado Home Winemakers Club, and so I was just like, "What do you guys want to learn about?" And they said nutrients, so that was like one of the presentations I wrote specifically for them. So, but anyways, okay, moving on. Secondary fermentation, malolactic fermentation. We're dealing with this with our wines right now. It's the conversion of malic to lactic acid. It's a beautiful thing. We have our cute little Enococcus eni bacteria consuming malic and pooping out lactic. Thank you, Wine Folly, for this cute image. Malic acid, so mal means bad in Spanish, right? Contributes to the sourness of green apples, so unripe fruit, right? Lactic acid is associated with yogurt, so it gives your wine a better mouthfeel. But there's lots of reasons why we use it. So I certainly hope so. I think it should. That would be awesome. Not to be confused with Mrs. Malolactic Bacteria, Mrs. Pac-Man. All right, so we have 3 family of lactic acid bacteria, and only really one of these is good. This Enococcus eni is the most popular. This is the one that we use most of the time. There's Lactobacillus and Pediococcus, and these are known to produce volatile acidity, so the vinegar smell in your wine. It can be vinegar or nail polish remover. So if you're starting to smell that, not a good time, not a good sign. So they can give some negative effects. They all reproduce asexually through binary fission. Exciting stuff. It looks like this. All right. Malolactic. Yes, yes, yes. Some in a lot of other parts of the fermentation science is considered spoilage. It's not spoilage for us. Most all wines in California and I can't speak on behalf of the world, but I know for California have gone through malolactic fermentation. I don't know if there's some ancient winemaking that are doing some other stuff out there, so I'm not gonna say something I'm not sure about. Okay, what happens during malolactic fermentation? This is important. So big star on the slide because this will most definitely be on the exam. 1, deacidification, right? Which means an increase in pH and a decrease in TA. Let's keep a finger on that. It gets confusing. Bacteriological stabilization, right? So you're consuming all the nutrients left in the yard, so that way all the raccoons and rats and other things don't come in and start bringing in the bubonic plague, right? Flavor and aroma change. So your choice of bacteria that you use, the timing of your fermentation, and also the sensory attributes that come during that time too. So this is why malolactic fermentation is actually not technically a fermentation. It's actually a deacidification. So put a star on that. That'd be a fun little trick question. I'd be like, true or false? Maybe I'm not that mean. But if you brought up deacidification, I would be very stoked. Might give you extra credit. All right, so this is malic acid, right? This is a carbon backbone. It's okay. If you didn't take organic chemistry, it's okay. And this is lactic acid, right? This double O in this OH group, this is a carboxylic acid group. That's what that looks like functionally. That's how we draw it in organic chemistry. So this bacteria bites off one of these ends, basically. It consumes it, and it releases it as carbon dioxide. And then you're left with lactic acid. So that's why it's a deacidification reaction. A compound with 2 acid groups becomes a compound with one acid group. That's what's happening there. And that's why carbon dioxide is being released and it's bubbling during that fermentation. Okay, so the deacidification leads to a better mouthfeel, right? We go from malic acid, a harsh green apple, to yogurt. Now it's the time for bacteriological stabilization. So you're removing all of the micronutrients from the wine, making the wine nutritionally poor, which is a good thing in this case because we don't want any of the harmful bacteria or yeast to come in and to utilize them and spoil our wines. So very, very ideal, multiple ways. Flavor and aroma change. So these are affected by your choice of bacteria, your timing of your inoculation. So you can do it during primary fermentation or after, and also the duration of your fermentation. So you have buttery or butterscotch character, or fruity characters, and better mouthfeel. Cool. All right. And we didn't make it in this class, but we could have. The secret to a buttery Chardonnay is malolactic bacteria. So the buttery compounds that are formed in Chardonnay, those diacetyls, this will be important, are produced from secondary fermentation. So, all right. Fruitiness. More fruit will come out because it's not covered by the acid. We're worried about the timing because lactic acid bacteria can produce vinegar. Yes, yes. All right. So, there was a question on the quiz about malolactic fermentation in a tank versus a barrel, right? So, I probably won't ask you that again. But just know that it's possible to do it in a tank. It doesn't have to be in a barrel. Cool. Paper chromatography. It's the best, right? Do we feel comfortable that we know what paper chromatography is? We didn't do it in class, but do you guys have a good feeling about it? Like,
I don't.
okay. It's okay. No, I'm glad you said something. So, paper chromatography, this will be on the exam. So, I'm glad you said something, Christine. So, paper chromatography is awesome because you can test at home, right? If you have the right chemicals and equipment, but it'll only tell you if the presence of the different acids in wine, right? So it'll test for malic, tartaric, citric, and lactic. Those are the four most like prominent acids in wine. So chromatography is the science of separating compounds. So this is a special sheet and a special solvent that's used to separate acids. So as this sheet soaks up this liquid, it pushes those compounds, those chemicals up the sheet, and then they will leave dots based off of like their polarity, so like their charge, or their sometimes it's their molecular weight or other components. So it does a very similar thing for us, but with acids, right? So what you would do, let's see if I have a good picture. We'll have to use this one. So what you'd do is you'd post a picture, or you'd put in your sample of wine, right? And with the wine sample, I wish I had a whiteboard right now, you get like 3 or 4 dots. Then you would post dots of standards, and those would also go to the same height as their corresponding dot. So, and I forget which one, how it works, but you can have a spot here. It could be malic acid, and it matches the spot on the wine sample, and then lactic acid, tartaric acid. Anyways, the big thing to take away is chromatography separates compounds. And it will tell you if malic acid is present, but it won't tell you how much. That's the downfall of paper chromatography. Try to keep it simple, sorry. That's the big takeaway you'll need to know for the exam.
Okay.
We don't do it in class because the chemicals are toxic. It's a huge pain in the butt, and we bought the Liza, so we're just gonna use the Liza instead. So yeah, that's the big takeaway. Yeah. Uh, what was that? Yeah, you can say that. Mm. It's awesome. All right. Last lecture, but not least. Now we have a lab to go through. Is sulfur dioxide. And Kathy, if you see anything, let me know. Okay. Sulfur dioxide. It's been used for a long time, and we used to burn sulfur wicks in barrels to prevent them from smelling like vinegar. It's still one of the most important additives used in winemaking, but it's also used in food science, just kind of across the board as a preservative, right? There's three forms of sulfur in the industry. We have sulfur, which is elemental sulfur. And we all like call them sulfur, which is like the really confusing thing. Like no one ever takes the time to say sulfides or sulfites. We all just say sulfur because we're lazy. So I apologize for that. So sulfur is elemental sulfur, right? It's present in proteins and used on grapes to prevent rot in the vineyard. It's very important. Sulfides and mercaptans. So if you open up a bottle of wine and it smells like rotten eggs or farts, that is sulfides or hydrogen disulfide, right? Right there. Those rotten egg and skunk smell produced when yeast and bacteria reduce sulfur to H2S. It's an example of reduced sulfur. It's what we call the smell reductive in wine. So that is a reductive wine, has sulfides in it. Okay, sulfites SO2, sulfur dioxide, so we use on the winemaking side of things, in all of its forms. This is an example of an oxidized sulfur. So, yes. Mm-hmm. Mm, that's a really good question. I know the strip itself is elemental sulfur, but I guess if you were burning it, it would become sulfite gas. That's a really good question. I'm not quite sure. Mm-hmm. With the like elemental sulfur into your barrel. No, I think. Well, I don't think you have anything to worry about. That's a very common practice that I still did at many local wineries. We would burn sulfur wicks in empty barrels all the time. Yeah, you're not like dropping it in the wine or anything. Mhm. Oh yeah, yeah, that happens. They make some with a basket on the end, but they're not very effective at burning because it doesn't let a lot of oxygen in. So yeah, it's a hard one. Yeah, yeah, I've burned lots of sulfur wicks in my time at Lewis Grace. Yeah, that was not a good time. Uh, okay, yeah, I wouldn't worry. I think you're okay, Ken. Yeah, I wouldn't worry about that. Okay, so we have molecular bisulfite and sulfite, right? So these are just the different types of forms of sulfur depending on the pH of the wine. And we'll talk about that in a couple slides. Okay, so there's three types of SO2, right? Free, bound, in total. So the type of SO2 that we're most concerned about in this class is free SO2. And that's because that's the SO2 that's available to interact with basically our soldiers on the ground, right? That can interact and help protect our wine. If it's bound, it's like me. It's in a bed all day. It's not helpful. It's not out in the field, right? But free and bound is your total SO2 altogether. There are legal limits for total SO2 that you can add to wine, and it's to keep people safe and not getting sick. We'll talk about that more in just a moment. So, this is important though, because if I had given you an exam question and I said, the total SO2 of your wine is 120 ppm, your free SO2 is 50 ppm, what is your bound SO2? You guys, you guys could calculate that, right? Because free plus bound equals total. So, and I'll put that. I'll be nice. I'll put that on the question. But yeah, you guys could calculate that, and that's what a lot of labs do. We can measure free and we can measure bound, but the most that we're concerned about is free in this class. We're never going to add an excessive amount or we're going to be over the legal limit. That's not going to happen. Huh.
Question for you here. On the
Yeah.
free SO2, so you have this chart where we match our pH with SO2.
Yes.
There you go. That's free SO2. So that's not
Correct.
total.
Correct.
Numbers you want. And your little the machine you have, when it gives us the SO2 level, that's total. So technically, we really don't know what the free is when you do the small wine sample measurement,
The
right?
the mid metrica should be giving you free SO2. It can give you total SO2. That test is a little bit longer, and that one includes adding extra acid to release the bound compounds. Yeah, it's capable of doing both. What we did in class was just free. Yeah, yeah, good question. And it looks like I had an edit. Yeah, it's the free. We could measure total if we wanted to, but it's hard to draw a line between the free and then when the bound start to come out. We either have to do free or total, and then just calculate the bound based off of that. Yeah. Mhm. Mhm. Um. Yes, that is. Um. Those are the like spoilage components and browning components of wine. Uh, I probably butchered that. Mm, 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 mm. Okay. So when alcohol comes into formation with oxygen, yes. Oh yeah. Here you go. UC Davis, help me out. All right. It's in a lot of cognac, big time. So you're just asking if it's a sensory compound? Sorry. It does have a smell. Um, but it is mostly associated with spoilage. Yeah. Excuse me. Okay. Perfect. Good question. Yeah, I won't ask you too much about this, but it just confirms like we talked about like we added 50 parts of sulfur to the juice or to the must during processing. Like we're not worried about it because so much of it becomes bound to the sugars in the juice and everything else that the fruit's bringing in from the vineyard that it will be consumed by the time we add our yeast to the fermentation. So now you know where that sulfur is going. You have another question? Okay. So, the important thing to remember about SO2 is another star on the slide. So, this would be like a 4 point or 8 point question. Um, is what is SO2? It's an antioxidant. It's also an antimicrobial. It helps to stimulate yeast, and it will also bleach red wine color, right, in extreme concentrations. So, it's an antioxidant. I need to look at this. Sorry, I don't think there was anything important there. Binds with Okay, go ahead and cross that off. I think I might have deleted that because I read something counterintuitive to that. So that will not be on the exam. Mhm. I have to look back into the fine print of the textbook on that one. Yeah, not with O2. Okay. Yeah. Okay. So it'll bind with oxidation enzymes that create browning color, and it can bind directly to acetaldehyde itself. It will also eliminate most yeast and bacteria on its own. It's an antimicrobial. And then through stimulation of yeast, it removes native yeast and bacteria that are unwanted in fermentation, right? So it helps the yeast that we purchased outcompete any native yeast in that situation. And it will also bleach color. So as an antioxidant, it'll block chemical oxidation reactions by reacting with oxygen radicals or with target compounds, not O2 directly. So oxygen radicals or target compounds. It don't worry too much about the fine print on this because this is not a chemistry course. Again, sometimes I have to reel myself back in with this class and remind myself there's no prerequisites for this course. If you would like to get into the depth of this, check out the textbook. The textbook goes into this, but we're trying to keep it just surface level understanding for this course for now. So polyphenol oxidase, this is the enzyme that creates browning in wine. So it'll inhibit the activity of that enzyme and thus preventing browning. There's also a little link here for you guys. So we talked about effectiveness depends on pH as an antimicrobial, so it'll inhibit native yeast and bacteria. And then that's what we reference this chart, right? This chart would actually be a really good question for your exam. And I think it's a really good reference. It just shows that the higher your pH, the more free SO2 that you need to defend your wine. Because the higher the pH, the more SO2 is needed. The higher the pH, the less effective SO2 is. That's why you have to add more. Okay. And this is just a chart showing that, but I will not quiz you on this or test you. Okay. So do we feel like we have a good hang on why it stimulates yeast? So Saccharomyces are basically super yeast that we've bred and developed to withstand higher levels of sulfur than native yeast. So I think of it as like Superman. And then so it'll help. So SO2 kind of helps so it can outcompete any native or negative yeast. And then we'll also bind to this enzyme, PPO, polyphenol oxidase, so it won't turn the wine brown. And yes, I did verify this. Cool. All right, effects on color. So it's okay if you're not a chemistry nerd, but I think this is really, really cool. So the way that we see things and see color and how color can come and go in an instant all has to do with these bonds in these benzene rings is what these rings are called, right? So you have alternating double bonds in these rings, and what happens is a combination of light with them actually it produces a color. It's really an interesting thing. Sulfur will actually bleach color. When sulfur comes in, it will disrupt this resonance, these like daisy chain of bonds. It will disrupt the bonds and it will leave the molecule colorless just by adding sulfur. Like that's all it takes to remove the color from that compound. So that is what can happen if you add extreme concentrations of sulfur to your wine. And you don't want that because you're going to be able to taste it and smell it, and it's not going to be pleasant by any means, right? However, it is a reversible reaction. You can actually add hydrogen peroxide to wine and it can remove sulfur. But I think one of the byproducts of that is sulfuric acid. So it's not really advised. I've never done it before, but I have heard of people doing it before. That won't be on the exam though. Anyways, sorry, focus. Okay, so are sulfites bad for you? This will be on the exam. So dried fruit contains anywhere between 500 to 2,000 ppm of sulfites, and wine contains between 20 to 350. So 350 is our legal maximum of sulfites. So yes, there are people who have been identified as reactive to sulfites in foods. Thank you. Yeah. So asthmatics, it's a small part of the population, so it is real. And it is a thing for some people, but the truth is that if you know someone who is worried about sulfites in wine, you can try just very kindly is the key word, educating them and ask them if eating dried fruit irritates them. If eating dried fruit does not irritate them, it's probably not sulfites and probably something else. That's okay. We have recently discovered one of the big culprits of headaches in wine, and I think it was posted in Discord, but UC Davis just came up with research on that. All right, and it was not sulfites. I believe so. I have to look back at the article, but there was something about triggering a allergic reaction or something like that in the wine. I believe it's posted on Discord. If I find it, I'll post it on the announcements for you guys. Yeah, but it's really cool and exciting discovery because sulfites have just been the scapegoat for so long. Like everyone is just sulfites this and sulfites that. Um, but it's used in a lot of products, right? So this is like a good image of that, right? Dry reds is very small compared to sodas, prepared soups, French fries, frozen juices, right? And why is that? It's because sulfites prevent browning. So these things are gassed where they use sulfites on them to keep them from looking brown by the time you consume them. Cool. So for this, the only thing I'll ask you to remember is the legal limit for the United States. If you decide to take a winemaking class in Australia, I applaud you, and then you'll need to know that. But for now, we're just here. So, 350 milligrams per liter is the same as ppm, and that is our legal limit in the United States, and that's for total SO2. So free plus bound. That's total, and this is a very high number. Um, it would take a lot of work to get up to 350. So but it is important when you work on a larger scale that you monitor that so you're not making people sick. All right, when do we there's a threshold for free SO2, but I don't know about total SO2. So free SO2 you can begin to smell it and taste it at 50 ppm, at 50 ppm free. Um it's tomato, so 50 milligrams per liter. Yeah, or equivalent. Yeah, good question. Yeah, so um yeah. Okay, timing of additions. This is important. So we don't want to add SO2 after primary fermentation, right? Because you need to add bacteria to start the second fermentation, and that would be sad. So it is important that you know when you add SO2. This will be on the exam. This could be a true or false. This could be a really tricky question, so make sure you just take the time to read it slowly. You should have plenty of time to take the exam. How do you know how much to add? Also, another good question, right? So we talked a little bit about this in class. So the condition of fruit, right? If the fruit is moldy or just looking very sad, then you might want to add more SO2. If the fruit looks perfect in textbook, maybe less. The type of wine you're making, the temperature. So like fruit came in hot. Some people wanted to add more SO2, right? Because the hot temperature started fermentation already. And so they wanted to kill any yeast or bacteria that was already potentially in the juice and in the grapes. And then also any movements. If you think that your wine or your juice is going to get exposed to oxygen, you can add a little bit more because you know that that will interact with the SO2 as well. Mm-hmm. Mm-hmm. Yeah, exactly. So that's why when like I pull a number out of the thin air where I'm like, we're gonna add 35 parts, all these conditions are taken into account when we come up with that magic number, right? We're like, man, this fruit looks like crap. We're gonna add straight 50. Like we're just gonna go for it more on this one or something like that. So 50 is like the max dosage, and that's if, say, the fruit comes in hot and it's moldy and it's already starting to smell like, acetic acid, or starting to smell like vinegar or rubbing alcohol or nail polish remover. Then you'd be like, okay, we need to like add 50, and also like do not cold soak. Like add your yeast right away so it can outcompete that funk. Um, if the fruit comes in and it's cold and it looks good and it's not starting to ferment, it looks very healthy, there's no mold. Yeah, just 35 would be fine, especially if you're going to inoculate it right away anyways. There's no need to add extra sulfur if you don't need it. Yeah, absolutely. No problem. Mhm. 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 Yes. Yeah. Yeah. Any bacteria, or like, or negative yeast that could have spawned either from that fungi or you know in addition to it on the fruit, because the fungi is consuming like sugars and stuff, right? So it's got a whole like biota of its own on that cluster that you do not want in your fermentation. Yes. Yeah, it could create flavors that are off or just unpredictable or just unsavory in your wine. Yeah. Hmm. Cool. All right. Then we have the calculation for sulfur additions. Done this a couple times in class, right? So for this, I will give you the gallons, um, and I will either directly give you the sulfur, or I will give you a beginning and an end desired sulfur. And that's where this delta comes into play, delta SO2, right? So if you have, one question could be, you have 1,000 gallons of Pinot Grigio, and the head winemaker has just been pressed, and the winemaker asks you to add 50 ppm to it. How many grams of KMBS you need? So just be 1,000 gallons times 50 ppm times 0.0066. That's pretty straightforward. If I gave you a question, another question might look like, you have 6 barrels of Primitivo, and it's currently at 12 ppm, and you want it to be at 35 ppm. How many grams do you need for each barrel? And assume each barrel is 50 gallons, right? So if you're doing dosages for individual barrels, be 50 gallons times whatever the difference of those two values I just said. I already forgot what they were. And then times 0.0066, right? Because there's already some free SO2 in the wine, and now you want to add on top of that. So you have to take that into account. Make sense? Yeah, difference, delta. It could be average in other practices. I don't know. All right. This is hydrogen peroxide. This could be a good question for extra credit. Um, yeah. Hydrogen peroxide is not meant to be ingested. Please don't do that. Um, this is just purely for the sake of science. I brought this up, but hopefully you're never in a position where this needs to happen. So just be careful with your sulfur additions. Sulfur will eventually dissipate over time, no matter what. Or you can always blend it out. But the products are water and sulfuric acid. So water is great for you. Sulfuric acid, not so much. So I wouldn't recommend it. Mm-hmm. 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 Yes, absolutely. Yeah. So yeah, splash racking, introducing the wine to oxygen will help bind some of that SO2 and get rid of it. Yeah, absolutely. It's like very vigorously as you're racking a wine from one tank to another, like on a large scale, you can take the hose and splash it against the sides of the tank and really like aerate the wine as it's being racked. Um, on a home winemaking scale, I'm not sure what that would look like. Mm. Okay. Yeah. Yeah. Sounds about right. Yeah. Yeah, sounds like a good idea. Yeah, that will absolutely help. And if you have a sparging stone with gas, like nitrogen or something, that can help also release it over time too. But it's just very expensive equipment. Um, yeah, just be careful. Just be careful not to overadd. It happens. It does though. Okay, then almost last but not least, we have our TTB, the Trade and Tax Bureau regulations for sulfites. So we always have to say that a wine contains sulfites if it's 10 ppm or above. If you are saying that you don't have sulfites, you have to prove to the government, you have to show them lab analysis that you are below 10 ppm. Wines that have less than 1 milligram can say no sulfites. So they're pretty hard on that. And this level must be shown by analysis. So then 350 ppm is our legal limit. Cool. Any questions on that? Okay, perfect. All right, we kind of went over pH already. And I don't think I'll be introducing anything new to the exam specifically on pH. So let's just go ahead and move over to titratable acidity. Do you guys know if I posted these slides online? Do you guys have access to these slides?
Oh, I didn't download
Okay. They should be under our files.
Oh, the TA. Okay, is it the, oh yeah, there it is. Titratable acid. Yep, I got it.
Should be. Okay. Yeah, just making sure. Just making sure. Of course, it's going to take forever to load. Okay, yeah. Okay, so it's in the lab folder under titratable acidity or total acidity and then titratable acidity slides. Okay. So, I know it's been a long time, but titratable acidity, why is it important? And how is it different than pH, right? So the big takeaways for the exam would be pH is stability and titratable acidity is sensory evaluation of wine, right? And if you had to pick one or over the other, go for pH. It's much more important that your wine is healthy and operating in a pH range that's good for the yeast and bacteria to thrive. Then you can deal with blending out any excess or lack of acid later. Okay, TA is reported in grams per liter. The TA ranges in grapes and wines all over the place. But it's also found, it's typically expressed in units of tartaric acid because it's the most prevalent acid in wine. Okay, this will be important. There's no direct relationship between pH and TA in wines, and that's why it is important to measure both. That would be a good true or false question. So what that means is just because the pH of one sample is 3.6 does not give us any kind of indication at all what the TA is going to be. The TA could be high or it could be low. There's no correlation, there's no general rule of thumb. They are two different measurements. Do you guys remember the example that we had with the girls in the bathroom in the dancing for titration? Okay, so does anyone need a recap on that delightful story? Okay, no worries. So when you think about the difference between pH and TA, right, and how we have to measure TA, we have to find out how much acid is in this solution by adding a base to it, right? Because that's what's happening in our mouth. Our mouths are basic. We want to measure the taste of acid in the wine. So undissociated acids in a solution that react with a strong base and be neutralized. So send out a boy at a time on the dance floor, and you'll slowly find out how many girls are left in the bathroom, right? They come into dancing partners and they go onto the dance floor and they neutralize each other. So that's why we add a strong base to this acidic solution. Okay, we talk about this. It's more important to have an ideal pH over an ideal TA. Stability is the goal, right? Titratable acidity is just what's happening in your mouth when you're tasting wine, right? So our mouth and saliva is relatively basic. Wine is acidic. There's a buffering process that happens in your mouth. So all of the acids that are exposed to the base dissociate into your mouth, and those are all the acids that you can taste. Okay. So for the calculation of TA, if I give you this on the exam, I'll give you the formula, and I will very clearly lay out how many milliliters of sodium hydroxide you use, the concentration or the normality, and then let you just use a calculator for that. Do you guys feel comfortable using this formula? Do you guys know what all these mean? It's okay. That's why I ask. You're good. So this is the calculation for TA, and it's in grams per liter of tartaric acid. So it's the milliliters of base. So the number of boys you added into the dance floor, right? Yeah, it's the base. Yeah, sodium hydroxide. Yeah. And then N is the concentration of that base. So normality of NaO. There's the concentration. And I'd lay this out nicely for you guys. I'd say you used 3 milliliters of NaOH. The normality was 0.1, blah, blah, blah. And then you would plug in the 0.075 times 1,000 divided by, then I'd say you use 10 milliliters of wine sample. You divide it by 10. And you should just use the formula. Yeah. Yeah. Oh, because they're both used as TA, right? Right, right. They're all commonly expressed as TA, but if you wanted to specifically say tartaric acid, I've seen a lot of people say HTA because the H is the acid group of tartaric acid. So it's used interchangeably, unfortunately. and and typically they'll give you the text along with the abbreviation so you can clarify which one is which. Yeah, but TA is expressed in units of tartaric acid um, because that's just the most prevalent acid in wine. I don't really know completely why they decided to do that. Tartaric acid or total acidity. Yeah, it's confusing. It's not very clear. If it was an HTA, it's definitely tartaric acid. But I've seen people casually on presentations refer to it as both. Okay. Then we have potassium bitartrate, which is just tartaric acid shaking hands with potassium and forming little wine diamonds. And it's not broken glass, I promise. This is just a cold stability reaction. But I don't think I'm going to ask you that on the exam. Just a fun fact. Okay, I think that is everything that will be on your guys'. Oh, wait, I lied. I know, I'm so sorry. I know some of you guys wanted the answers to this, so I'm just going to go through the answers really quick. Yeah. Yeah, I lost your guys' labs. I don't know where they went. I'm so sorry. Yeah, both yours and Ken's and Dawn's. I tried looking for them. I had no idea where they went. Yeah, I'm so sorry. Yeah. This is the PHTA lab. We measured pH and titratable acidity. Hmm. Yeah, so Christine, I think I don't know, I'll have to look at your grades. I'll take a look. We'll figure it out. But we'll go over the answers now. So you guys have it if you need it for the exam. Okay, so for a red wine, the lower the pH, the more or less vibrant the wine is. So if it's a lower pH, it's more acidic, right? So it'd be more vibrant. So more acid, more vibrancy, less acid, it's more dull. Okay, how would a low pH wine taste compared to a high pH? So a low pH wine would taste sharp and acidic, and maybe even potentially bitter. A high pH wine would taste flabby. That is the technical term for it. I don't like it, but that is the technical term. This is flabby. So offensive. All right. At what stages do you think you'd measure pH in your wine? So this is kind of vague. In your wine, right? Well, we'd want to measure it when the grapes come in at harvest, right? So at crush. We'd also want to measure it so we can make any adjustments if needed, right? And then we just let it run through primary and then secondary fermentation. So we'd want to measure it after secondary fermentation and make any adjustments there. And that's mostly it. You can check it at other times too. Those are the big times to really check and adjust pH. You don't want to do it right before bottling because adding acid right before bottling could create a destabilization reaction, and you could have fallout with the those wine crystals we just saw in your bottles. Okay, what would you add to your wine to lower the pH? So to make it more acidic, we would add tartaric acid or citric acid or an acid-X blend, whatever your pleasure. And if you wanted to raise the pH, if you wanted to make it less acidic, you would add. Dun, dun, dun. Is it in this one? I'm losing my mind. There's a couple options, right? Oh, maybe it was in the pH lab. Aha! Here we go. Calcium carbonate, potassium bicarbonate. Wait. Yeah. Or acid-X. Carbonate. Mm-hmm. Or potassium bicarbonate. Sorry. Or acid-X. That would be the answer to that one. All right. What is TA a measure of in wine? It's the total acidity, right? So sum of total organic acids in a wine. And it's in grams per liter units. Why is acid important in wine? Acid is the health, right? The stability of a wine. It will drive the success of your fermentation, the health. This is a good one. At what pH do we titrate to when we measure total acidity, which is also known as our end point? And you remember this from the lab?
8.2 or something.
8.2. Yeah, good job. Good memory. Yep, 8.2. It's all good. All right. What can be a major cause of interference with your TA measurement? One would be your pH probe is not calibrated correctly, right? If it's not calibrated, you're not getting to the right endpoint. Um, not yeah, chunks floating around is not a good time. Yep, that's also one. Um, adding the incorrect amount of your chemicals that you need. Um, not submerging not adding enough water so you can submerge the probe, right? If the probe is only partially in solution, then you're not going to get a proper measurement.
Yes, and over adding at the very end, right when it starts.
Yeah. Yeah, absolutely. Yeah, it can be very easy to over titrate. Absolutely. Okay, last but not least, why is it important that you wait until the pH stabilizes before continuing to add more titrate or, base, sodium hydroxide to the solution? So, just like you said, Christine, it's very easy. At a certain point, the number will start to spike. And so you'll be adding a lot of base for a little bit there, and then it's going to be hard to move that number of those pH units. But as you get towards the end, it starts to skyrocket. So it's very important that you let it stabilize. You can see how much it's moving, so you can add just a little bit at a time at the end. Because otherwise, you just overshoot it. So, not a good time. Okay. Any questions? Well, if you think of something, feel free to email me. It will be on my computer. On this lab. For a red wine, the lower the pH, the more or less vibrant the wine is. So the lower the pH, the more acidic it is. The more acidic, the more vibrant the wine is. And the less acidic, the higher the pH, the more dull a wine looks. Yep. Cool. All right. Well, thank you guys for coming today. Like I said, if you have any questions, just shoot me an email. I will start working on this exam, and it'll be available for you guys next week, starting at 8 a.m. Cool. Thank you guys. Thanks for coming tonight.
Any question now that maybe stop